Welcome! Today we're going to learn about simplifying trigonometric expressions. So here is the example we're going to do today, and you can see that here in green. So what are we going to do? Well, first thing I usually tell students, when you look at the expression, I want you to first use your algebra rules. In other words, in this particular example in 1, if you look within the parentheses, you see that you have two terms, tangent and then tangent theta sine squared theta. Separated, both terms are separated by a minus sign. And you can factor that tangent of theta out because it's common to both of your terms. It's just as though, if you think of it this way, think of tangent of theta as x and think of sine squared theta as y. Then that expression would really be x minus xy. And if you had that in parentheses, you could factor out the x because that would be common. So it's the same concept. You're using algebra rules even though it looks like a trig function. Okay, so that's the first thing we're going to do. Now, factoring out does not always work to simplify. You really have to kind of play around with it and see whether it's helpful or not. But that's what we're going to do in this case. The next thing we want to do, again, if you look in item 1, we've rewritten our expression the way it is now. We, again, look to see if there are simple algebra manipulations. In other words, can I cancel something that's common in the numerator to the denominator, but I don't see anything like that. So the next step is, well, can I make a trig substitution using my trig identities? And in item 1, you can substitute 1 minus sine squared of theta with cosine squared of theta using a trig identity. Now I've listed it below in item 3. You can see in item 3 it says cosine squared plus sine squared equals 1. And if you subtract sine squared from both sides of that equation, you wind up with cosine squared equals 1 minus sine squared. And that is what we replaced. In other words, we took out the 1 minus sine squared and we replaced it with the cosine squared. Now, how did I know to do that? Let me just give you a tip. When you look at your expression, as we have in item 1, if you see the term 1 or the term sine squared or the term cosine squared, right away I want you to think of using the identity we used in item 3, possibly to substitute. Okay? Again, you have to play with these things. They don't always benefit you, but if it looks like you're going to come up with something simpler, then you've chosen the right substitution. Okay, so we've rewritten our expression as we have it now in item 1, just to remind you what we have. And again, we want to look, is there any simple algebraic simplification? Not really. We've got 4 different functions. We've got tangent, cosine, secant, and sine. Cosine squared actually, but and then we want to, so that doesn't work. So then the next thing, do I see an obvious trig identity substitution that might be beneficial? And it may not be so obvious here. So if that's the case, when all else fails, best resort is replace everything with sines and cosines. Why? Well, if everything's in sines or cosines, there are only 2 options, and the chances are something's going to cancel. So that's what we're going to do here. If you look in item 1, we have circled the tangent of theta, and if you follow the arrow down to item 2, we have replaced that with sine of theta over cosine of theta. You must know that trig identity, obviously, to make that adjustment, but that is what tangent of theta is, sine over cosine. Then if we go back to item 1, we have circled the secant of theta, and if you follow the arrow down, you will see we replace secant with 1 over cosine, again using a trig identity. Now, the good news, everything in item 2 is sines and cosines. And that's great news because the chances are, again, if you look at this as an algebra problem, let's just say we call sine x and we call cosine y, then you're going to see where a lot of these terms are going to cancel. So let's start canceling. In item 1, we have sine of theta in the numerator, sine of theta in the denominator. Clearly we can cancel them. They're the same thing, just like x over x. Then we have cosine squared in the numerator, and we have cosine of theta and another cosine of theta in the denominator, but they're multiplied. Clearly cosine times cosine is cosine squared, so you really have cosine squared in both the numerator and the denominator. You can cancel those, and you are left in item 2 with 1. So we started with something very messy, and we wound up with 1. And that is simplifying trigonometric expressions. Now go practice, practice, and practice some more.